So, hello everyone. Can you hear me? Hello everyone. Good evening. So, I am Mansha Mishra, and I am a PhD scholar in the Department of Applied Mechanics, IIT Madras. And in this tutorial, I am going to solve few example or the tutorial problems related to the NPTEL videos in the subsequent week. I mean, in the previous week. So, in the previous weeks, you might have seen the lecture videos related to the equilibrium of forces and the forces, the basic concept of forces at all. So, in this tutorial, we will going to solve few concepts which are related to the balancing forces, equilibrium forces, movements, or taking the summation of movements. So, we will be solving some couple of example of that. So this tutorial will be recorded and will be uploaded in the YouTube, as well as I will upload this presentation slides in the Google Drive as well. So let's start with this question first. So in this question, we have if F1 force is 150 Newton and phi is 30 degree, determine the magnitude of the resultant force acting on the bracket and its direction measured clockwise from the positive x-axis. So in all the question that we are going to solve today, we have to do the force balance and moment balance. So that is one of the basic concept that you might have gone through the video, NPTEL video in the first week. And related to the such concept, we will be solving the multiple questions here. So in this question, we have to find the resultant force and its direction, or sorry. So this might be a displaced one question. Let me. There was another one. So actually, the real question is here. So this is the real question. So the question is, if the magnitude of the resultant force acting on the bracket is 450 Newton, directed along the positive u-axis, determine the magnitude of force F1 and its direction phi. So let's make the first free body diagram. So I have x-axis and here I have the y-axis, and here we have a three forces F1, F2 and F3. Can you please mute your hello? Vidyadhar, if you don't have any question, can you please mute? So anyway, we have a force F1 here, and we have a force F2 here. Unmute your mouth. Hello? Vidyadhar, are you going to are you saying something? And then we have a force F3 here, which is of 260 Newton. And force F1 we need to find, and this is my F2, 200 Newton. And there is one axis, U, which is at 30 degree. And this is my phi angle, which we need to find out. And it is said in the question that there is a resultant force which is acting along the positive u-axis. So there is a resultant force along this axis, which is Fr. So let me make the diagram separately for the Fr here. So this is my x, this is my y, and this is along the u-axis, Fr. which is 450 Newton. And then let me write down or draw the components of this resultant force, which is here it is Fry and here it is Frx, and this is 30 from the x-axis. Similarly, I can actually draw the components of the force F1 and F3 as well, because they have some inclination from the x-axis and the y-axis. So for the F1, let's say, let me draw with the blue color. So this is my F1y, and this is my F1x. And from the green color, let's say this is my F3y, and this is my F3x. So this F3x, F1x and F2 all is along the x-axis. So I'm drawing a little lower because I need to make it identify that F3 is along the x-axis. And we have given the directions here. So you can see in the question that we have given the component here, which is 12, 13 and 5. So now we have to do the force balance. So see, my voice is there, right? Because I think somebody says I am muting my mic. So you can able to hear, right? So
I can hear you, but your voice is very low.
Okay. Let me just put it. Is it fine now?
Yeah, it's okay.
Okay. So now, yeah, okay. Now try to write the component of this forces. So let's start with the force F1. So in the horizontal, so let me create a table. So this is my horizontal and this is my vertical component of the forces. So now we have F1x, which is, and you can see here, these are the components of F1. And the F1x is basically the sine component, so it will be F1 sine phi. And the vertical component F1y is given by F1 cos phi. Now for the F2, we have given 200 Newton because it's acting along the x-axis. So the whole force in the x-axis is 200 Newton. So this is 2x and F2y is 0 because, as I said, the force is acting along only in the x direction. Now F3x should be in the, we need to find out in the x direction here. So it will be F3 5 by 30 and F3y will be 12 by 13. So it is F3 12 by 13. So this is my y component of the force. So basically you can see if you are making an angle here, some angle, let's say alpha, this would be the sine alpha and this would be the cos alpha. And you also know about the F3, which is 260 Newton. So now we have figured out the horizontal and the vertical component of each force. Now we can do the summation of horizontal forces. Now the summation of the horizontal forces actually equal to the reaction or the resultant force. So this resultant force in the x direction. So basically all the summation of this horizontal force in a specific direction, let's say x, will be equal to the resultant forces in the x direction. And similarly, all summation of the forces in the y direction will be equal to the resultant force in the y direction. So basically, the x component of force will be, now we just need to add all these component of the forces. So it will be F1 sine phi plus 200 plus F3 5 by 13 equal to, so here my FRX is FR cos 30 and FRY equals FR sin 30. And we know that FR is 450 along the U direction. So it is given in the question, which is 450 Newton. So it's 450 cos 30, which will give you 389.7 Newton. And this is FRY, which is 450 sine 30, which will give you 225 Newton. So my resultant summation of Fx will be equal to 389.7 Newton, which is here 389.7 Newton. So every quantity is in Newton here. So this is my equation 1. Now the same thing I can do with the y-axis. So my summation of all forces for the y component is equal to my resultant forces in the y direction. So again I need to club all this force. I need to do the summation of all these forces. So it will be F1 cos phi plus 0 plus F3 12 by 13 equal to my resultant force in the y direction, which is 225 Newton. And this is my equation 2. So I can also replace F3 with 260 because we know that F3 is 260 here. So it's 260. This is 260. So now we have in this equation we have two unknowns. So the first unknown is F1 and the second unknown is phi. So we have two unknown and we have two equations. So we can solve this equation together to calculate these two unknowns. So now I have let's take equation 1 and we have F1 sine phi plus 200 plus and it will be 260 divided by 5. It will be 100. So this This quantity will give me 100 here. So it will be 100 equal to 389.7. And on solving this, I will get F1 sine phi 389.7 minus 300, which is F1 sine phi 89.7. So let's say this is 3, equation number 3. Now I take equation number 2 here, and I will get F1 cos phi equals 225 minus 260, 12 by 13. So I will get 260. So this quantity is so in the y component, I have F1 which is going in the positive y. So yeah, sorry. So this would be the minus sign here, because the F1 component going along the positive y axis, and so does the resultant force in the y direction, but the F3 component going in the negative y direction. So F3 in the y direction will be negative here, so this will become positive. This will be the positive. And this quantity will give me 240. So the overall quantity will be 465. So it is 465 equals to F1 cos phi, which is equation number 4. So now we actually simplified these equations. And now we can use equation number 3 and 4 directly. So we can divide equation number 3 with equation number 4, because when we divide, we have F1 sine phi equals 89.7 divided by equation 4, which is F1 cos phi equals 465. So this will give me sine phi by cos phi equals to tan phi equals 89.7 divided by 465, so which is 0.192. And then the phi will be tan inverse 0.192. So if you calculate the phi, you will get in degree, which is 10.9 degree. So this is the phi. Now you can substitute the value of phi in any of the equation, like equation 1, equation 2, 3 or 4. It's better to substitute in 3 or 4 because we already simplified the equation, so the calculative label will be very less. So F1 sine 10.9 equals to 89.7. So F1 will be 89.7 divided by sine 10.9 degree. So if you're calculating this, you will get the F1 as 474 Newton. So this and this will be your answer. So just to recap, we have given the system where we have a multiple forces which is acting, and these forces are actually co-current in nature because it's acting at a single point. And now it is said that there is a resultant force which is acting along the u axis, here Fr, and we need to identify F1 and this angle phi. And to do this, we first figure out the components of all the forces. We figure out the component of F1, F2, and F3, and also the resultant forces. And then we take a summation of its component, which we equate it to the resultant force component. And then we solve these two equations together to find two unknowns, which was F1 and phi. So any doubt in this question? Is this one clear? Okay. So let's move to the to find the resultant. To find the resultant, you need to first find the components of the forces. So first let's say wait a minute. So for example, let's say you have a coplanar forces, which is let's say here it is F1 and this is F2. And this is your some resultant here. Now in order to find the resultant, it is just a vector addition of these two forces. Now you can actually find the component of these two forces, which is so this is your F1y and this is your F2y, and this is your Rx, this is your Ry, this is your F1x here, and this is your F2x. Now the resultant will be given as the vector addition of F1 and F2, and F2 and F2 can further be splitted. So F1 can be given as Fx and Fi, and so does F2, which is
F2x
F2x
and
and
F2y
F2y
j.
j.
And
And
one
one
can
can
add these
add
two
these two
forces,
forces,
which will
which will
give
give
you
you
Fx,
Fx,
sorry,
sorry,
F1x
F1x
I,
I,
F1,
F1,
sorry,
sorry,
F1y
F1y
j
j
plus
plus
F2x
F2x
I
I
plus
plus
F2y
F2y
j.
j.
So this
So
is
this
our
is our
overall
overall
resultant.
resultant.
Now you
Now you
club the
club the
x
x
components
components
together,
together,
which is
which is
F1x
F1x
plus
plus
F2x
F2x
I
I
component
component
plus
plus
F1y
F1y
F2y
F2y
the
the
j.
j.
And
And
this
this
one
one
is
is
actually your
actually your
Rx,
Rx,
and this
and
is
this is
actually your
actually your
Ry.
Ry.
So
So
basically,
basically,
this
this
is
is
how you
how you
actually
actually
get the
get the
resultant
resultant
from the
from the
components
components
of the
of the
force.
force.
Here,
Here,
in this
in this
question, what
question,
we
what
have
we
done,
have
we
done,
have
we have
already
already
given
given
the
the
resultant
resultant
forces.
forces.
We
We
just
just
found the
found the
component of
component
it.
of it.
So, for
So, for
example,
example,
we have
we have
given this
given this
Fr,
Fr,
which
which
is
is
450
450
Newton,
Newton,
and it
and
is
it is
acting
acting
at
at
30
30
degree
degree
from the
from the
x-axis.
x-axis.
This is
This
my
is
y
my
and
y
this
and
is
this is
x.
x.
So we
So we
just
just
found the
found the
component of
component
these
of these
forces.
forces.
We
We
found
found
this
this
Frx,
Frx,
sorry,
sorry,
this is
this is
y,
y,
Fry,
Fry,
and
and
this
this
Frx,
Frx,
or I
or I
should
should
write
write
here
here
Frx.
Frx.
So
So
this
this
Frx
Frx
will
will
be
be
Fr
Fr
cos
cos
30,
30,
and
and
Fry
Fry
will
will
be
be
Fr
Fr
sin
sin
30.
30.
So
So
we
we
just
just
use
use
this
this
component
component
to
to
calculate the
calculate the
summation,
summation,
to
to
equate it
equate
with
it with
summation.
summation.
We
We
did
did
not
not
actually
actually
calculate the
calculate the
resultant
resultant
because it's
because it's
already
already
given.
given.
But in
But
order
in
to
order
find
to
the
find the
resultant
resultant
for the
for the
given
given
system of
system of
forces,
forces,
you
you
can
can
do the
do the
vector
vector
addition.
addition.
So
So
if
if
you
you
have
have
any
any
other
other
question, you
question, you
can
can
ask or
ask or
write it
write
up.
it up.
In real life, where that coplanar force will act?
Uh,
Uh,
can you
can you
please
please
repeat?
repeat?
In real time, how that coplanar force will act like that you drawn, right?
Yeah.
Yeah.
So
So
usually the
usually the
coplanar
coplanar
force will
force
be
will be
acting at a
acting at a
single
single
point.
point.
For
For
example,
example,
let's say
let's say
this is
this
our
is our
F1
F1
and this
and
is
this is
our
our
F2.
F2.
So you
So
can
you
say
can say
that the
that the
line,
line,
so
so
these
these
two
two
forces have
forces
a
have a
single
single
point.
point.
So
So
these are
these are
the nature of
nature
the
of the
coplanar
coplanar
force.
force.
But
But
here
here
what
what
happens
happens
that
that
you can
you can
actually
actually
change the
change the
line of
line of
action of the
action of the
forces.
forces.
So
So
for
for
example,
example,
let's say
let's say
this is
this
our
is our
point
point
B
B
and this
and
is
this
our
is our
point
point
A,
A,
and there
and
is
there
a
is a
force
force
which is
which is
acting
acting
P.
P.
So you
So you
can
can
change
change
this
this
point.
point.
You
You
can
can
exert
exert
the
the
same
same
force
force
P
P
at
at
point
point
A,
A,
and
and
what
what
happens, the
happens? The
overall
overall
system will
system will
not be
not be
get
get
affected
affected
by
by
this
this
change of
change of
force.
force.
So
So
there is
there
a
is a
line of
line of
action.
action.
So
So
there
there
is
is
such a
such a
line of
line of
action,
action,
and you
and you
can
can
actually
actually
slide the
slide the
forces
forces
along
along
this
this
line
line
of
of
action,
action,
such
such
that
that
the
the
overall
overall
system is
system
not
is not
affected.
affected.
So
So
even if you
even
have
if
a
you have a
coplanar
coplanar
force here,
force here,
you can
you can
actually draw
actually
like
draw
this
like this
also,
also,
or
or
so it
so
will
it will
become
become
this
this
F2
F2
and
and
F1.
F1.
Or you
Or
can
you can
also draw
also draw
like this.
like this.
So
So
this
this
is
is
F1
F1
and this
and
is
this is
F2.
F2.
You can
You can
also
also
draw
draw
F2
F2
here.
here.
So
So
in
in
such
such
cases,
cases,
in
in
all
all
these
these
cases,
cases,
you will
you will
get
get
the
the
different
different
resultant
resultant
vector.
vector.
So
So
for
for
example,
example,
here
here you
this is
this
the
is the
resultant
resultant
vector.
vector.
Here
Here
this is
this
the
is the
resultant
resultant
vector,
vector,
and
and
here
here
this is
this
the
is the
resultant
resultant
vector.
vector.
So
So
this
this
is
is
how
how
actually
actually
you
you
slide
slide
down the
down the
different
different
forces in
forces
a
in a
coplanar
coplanar
system.
system.
Where a
Where a
coplanar
coplanar
system is
system is
such
such
system where
system
you
where
have
you
a
have a
multiple
multiple
force at
force
a
at a
single
single
point.
point.
Okay, sir.
Well, I don't have much idea about the exams, but I think it will be mostly MCQs, like like your assignment maybe. So let's move to the next question. So this is pretty similar question that we have solved, but just the arrangement of the system gets changed. So here we have the ball D has a mass of 20 kg, and if a force of F 100 Newton, which is this one, equals to 100 Newton is applied horizontally to the ring at A, determine the dimension D so that the force in the cable AC is zero. So we need to determine this value of this D, and provided that the force in this cable will be zero. So basically, when we do the summation of forces along the x and y direction, we just need to ignore it because this is the zero. Force is zero here, which means the force AC will be zero, and the component of AC will also be zero. So when you do the force balance equation, what you do, you actually consider all the forces, all the components of forces like force due to AB, force due to AC, and this force 100 Newton as well as the weight. Now you have a situation which is that we will talk after some questions because first we will be actually solving the question by using the summation of forces. Then we will be try to solve question which also contain the summation of movement. So what happens in the earlier question you got two unknown quantities. For example, the unknown quantity was F1 and phi, and you had two equation which comes from the summation of horizontal component forces as well as the summation of vertical component of the forces. So you got two equations and two unknowns. So which means that you can easily solve this set of linear equations to actually calculate the unknown value. But let's say you have a question where you have three unknowns or more than two unknowns. Let's say there is one another unknown which is some reaction forces R. Now in that case you need to solve three equations. So the two equation you already have with the force balance, which is come from the summation of x component and the y component of the force. The third equation actually you will get when you sum the moment around some or any point. So in this case now you will have three equations, two force equation and one moment equation. So in that case you can actually calculate the three unknowns quantity. So in the previous question what happens, we did not need to use the moment balance because we can able to get the unknown quantities by force balance itself or the summation of force itself. But yeah, we will be solving few questions where we have to do the moment balance in order to get the unknown quantities. That we will be look shortly in the subsequent questions. Well, and also it is true, like in order to have a body which is in complete equilibrium, in order to define the complete equilibrium, the body you need to equate the summation of forces equal to zero as well as the moment. So the summation of forces and summation of moment both should go to zero. So let's come back to this question. So now we have to consider the component of all these forces, but the condition is given that the force AC is zero. In that case, we need to ignore this. So the component of this force will be 0, and we will be using remaining three forces in our analysis. So let's make the free body diagram first. So it will be force F here, and this will be weight, which is 20 kg. And then there will be some force, which is force AB, which is acting at angle theta. So now the summation of x component of force is 0, and it will be F minus FAB cos theta equal to 0. And this is my equation 1. The summation of Fy will give us W minus FAB sin theta equal to 0. And this is my equation 2. And W here is 20 into 9.81. So this will give me, so from equation 2, so F is there, right? So here we have given FAB. No, sorry, F. So let's consider equation 1 only. So it will be 100 equals to FAB cos theta. And equation 2 is 196.2 equals FAB sin theta. Now we can again divide the both to get sin theta by cos theta equals to 196.2, 100, and this will be tan theta equals 1.962. So theta will be, on solving this, I will get theta as 62.9 degree. And when I substitute back into 1, I will have 100 equals FAB cos 62.9, which is FAB 100 cos 62.9, which will give me FAB equals to 220.21. So basically I got this force FAB, and I got this angle also. This angle, which is theta. So well, we did not need to find the FAB. So we already have a theta here, which is 62.9. So now we can use this theta. So this is theta, and this is 2 meter. And we need to find D, which is this. And this is my 1.5 meter. So basically then my tan theta will be D plus 1.5 divided by 2, and my theta is 62.9 equal D plus 1.5 by 2, so it will be 2 tan 62.9 degree D plus 1.5. And on solving this,
you will
you will
get
get
d
d
as
as
2.42
2.42
meter.
meter.
So
So
basically
basically,
we
we
do the
do the
summation of
summation of
force
force
in
in
order to
order to
find the
find the
theta.
theta.
Yes,
Yes,
yes.
yes.
So
So
W
W
will be
will
in
be
the
in the
negative
negative
direction,
direction,
but
but
it will
it will
give me
give
the
me the
same
same
equation
equation
because
because
eventually
eventually
you are
you are
taking
taking
any of
any of
this
this
part
part
into the
into the
right hand
right hand
side
side
and
and
you will
you
end
will
up
end
with
up with
this
this
same
same
equation
equation
here.
here.
So
So
just to
just to
recap,
recap,
we have
we
done
have
the
done the
force
force
balance
balance
equation to
equation to
calculate the
calculate the
theta,
theta
like
like
in the
in the
earlier
earlier
question,
question,
and
and
then we
then we
use
use
the
the
geometric
geometric
aspect
aspect
of
of
this
this
triangle
triangle
to
to
calculate the
calculate the
unknown
unknown
quantity,
quantity
which is
which is
d.
d.
We
We
don't
don't
have
have
to,
to,
I mean, here
here
calculate the
calculate a
force
force
AB.
AB.
So
So
any
any
doubt in
doubt in
this one?
this one?
So if
If
not,
not,
then
then
let's
let's
move to
move to
the
the
next
next
question.
question.
So
So
here we
here
have
we
the
have the
forces
forces
F1
F1
equals
equals
30
30
Newton
Newton
and
and
F2
F2
which
which
is
is
80
80
Newton
Newton
and
and
F3 which
F3
is
which is
40
40
Newton,
Newton,
and we
and we
need to
need to
figure
figure
out the
out the
movement of
movement
the
of the
forces
forces
about
about
point
point
A.
A.
So
So
basically in
basically
the
in the
movement,
movement,
the
the
magnitude of
magnitude
the
of the
movement
movement
can be
can be
given by
given
the
by the
force
force
multiplied
multiplied
by
by
its
its
perpendicular
perpendicular
distance
distance
d.
d.
So
So
in
in
order
order
to
to
find the
find the
movement
movement
at
at
about
about
this
this
point,
point,
we
we
need to
need to
first
first
identify the
identify the
forces
forces
which is
which is
actually
actually
creating the
creating the
movement.
movement.
So for
So for
example,
example,
I
I
have
have
F3.
F3.
I
I
have
have
given
given
first
first
F3
F3
and there
and
will
there
be
will
a
be a
two
two
component of
component of
this
this
force.
force.
First,
First,
so
so
let's
let's
say
say
this is
this is
my
my
x
x
axis and
axis
this
and
is
this
my
is my
y
y
axis.
axis.
So
So
here
here
you will
you will
have
have
F3y
F3y
and here
and
you will
here you
have
will have
F3x.
F3x.
Similarly for
Similarly
the
for the
F2
F2
you
you
will
will
have
have
F2x
F2x
here
here
and
and
here you
here
will
you will
have
have
F2y.
F2y.
Now
Now
you
you
need to
need to
figure out
figure out
which
which
of
of
these
these
forces,
forces,
including the
including the
component of
component
this
of these
forces,
forces,
is
is
actually
actually
creating the
creating the
movement
movement
at
at
point
point
A.
A.
So
So
this is
this
my
is my
point
point
A
A
here.
here.
So
So
definitely the
definitely the
force
force
F1
F1
is
is
not
not
creating
creating
any
any
movement
movement
because
because
it is
it is
itself
itself
at
at
that
that
point.
point.
So
So
if the
if the
movement
movement
lies
lies
in the
in the
line of
line of
action
action
of
of
any
any
forces,
forces,
the
the
movement
movement
due to
due to
that
that
forces will
forces
be
will be
zero.
zero.
So
So
for
for
this
this
forces,
forces,
this is
this
my
is my
line of
line of
action.
action.
And if
And
we
if we
need to
need to
figure out
figure
the
out the
movement
movement
at
at
some
some
point
point
which
which
contain
contain
in the
in the
line of
line of
action,
action,
then the
then the
movement
movement
due to
due to
that
that
force will
force
be
will be
zero.
zero.
So
So
for
for
force
force
F1,
F1,
this is
this
my
is my
line of
line of
action
action,
and the
and the
point A
point A
located at the
located at
line
the
of
line of
action
action
itself.
itself.
So there
So
will
there
be
will
no
be no
contribution of the
contribution of the
movement due
movement
to
due to
force
force
F1.
F1.
Now
Now
for the
for the
force
force
F3,
F3,
so
so
first let's
first let's
consider for
consider for
F3x
F3x
here.
here.
Now there
Now
is no
there is no
perpendicular
perpendicular
distance of
distance of
force
force
F3x
F3x
to A.
to A,
And
and
therefore
therefore
what
what
happens,
happens?
the
The
contribution of
contribution
for
of for
F3x will be
F3x will
not
be
there.
not there.
But
But
for
for
F3y,
F3y,
the
the
perpendicular
perpendicular
distance
distance
to
to
A
A
is
is
this,
this,
is a
is a
vertical
vertical
distance
distance
actually.
actually.
Sorry,
Sorry,
is
is
actually
actually
this. This
this.
is my
This is my
perpendicular
perpendicular
distance,
distance,
which is
which is
8
8
meter,
meter,
and this is
and this
my
is my
F3y.
F3y.
So there
So
will
there
be a
will be a
contribution
contribution
from
from
F3y.
F3y.
Now
Now
similarly
similarly,
for
for
F2x,
F2x,
my
my
perpendicular
perpendicular
distance is
distance is
given by
given by
this,
this,
which
which
is
is
2
2
meter,
meter,
and this
and
is
this is
my
my
F2x.
F2x.
And
And
therefore the
therefore the
F2x will
F2x will
create a
create a
movement
movement
around
around
point A.
point A.
So
So
again
again
F2x will
F2x will
be
be
there,
there, and it will create a movement about point A. But for F2y, again, my perpendicular distance for the F2y is actually this horizontal s- length. And you cannot, there is no perpendicular distance uh, to point A. And therefore, again, the F2y will not create any movement. Okay, because there is no perpendicular or the normal distance to point A. So only forces among F1, F3, F2, and components of F3 and F2, we have only two component of force, which is actually creating a movement. So we have to consider only these 2 points. Now the second point is you need to actually consider the direction of a movement. So here, and you can choose it arbitrarily. For example, let's say here I choose my counterclockwise direction as the positive and the clockwise direction as the negative direction. You can also choose in a reverse way. It's completely random. Now we need to consider these two forces. So the movement about point A will be due to F3y. So you can actually check. So what happens? This is your point A, and F3y about point A is actually going in the counterclockwise direction. So this is my F3 and it is approaching A in the counterclockwise direction. So this is positive actually. F3 y is positive multiply by its normal distance, which is 8 meters. And this is the component. This is the F3y is the component of F3. So if this is our F3, this is our F3x, this is our F3y, and this is 30. So F3y is equals to F3 sine 30. So this is multiplied by sine 30 because we are talking about the component. Now similar thing we can do for the F2x, which is creating a movement here. So this is my F2x, again the component of F2, which is F2 cos 45. So this F2 is approaching point A again in the counterclockwise direction. Okay, so this is again revolving in the counterclockwise direction about point A. So this is very good visualization to check the sign of the movement. For example, let's say I am considering the movement about C. Okay, so what happens? F2x creating a clockwise movement about C. So about C, there you have to add the minus sign. So the movement is actually negative because it's a clockwise movement around C. But around A, you have a counterclockwise direction. So you need to consider the positive sign here. So it will be F2 x cos 45 multiplied by normal distance, which is 2. So now you need to calculate it. So it will give you, so your F3 is 40. Sorry, this is not Y. Because we took the component here. So now it's 40 multiply 8 multiply by 1 by 2 plus F2 is 80 1 by 2 2. So we will be calculating this now. So this is 160. This is about 114.28. and it will be 274. So this 274 is positive, which means the moment about overall summation of movement about point A is counterclockwise direction because it's a positive movement. So the answer is 274. So just to recap, there are actually two steps only to calculate any quotient related to the moment. First is you need to identify the forces which is creating the moment, which we have done here. And we figured out that F3x and F2y is not creating any movement, only two forces are creating. Then once you decided which force are creating the movement, then decide the sign and it's your choice. So you can take counterclockwise as positive or negative. No, so couple what happens, there are two no, parallel forces which are acting. So it's a part of a movement. So in a couple, let's say this is your point O. There is actually two forces which have a opposite nature to each other. For example, the one force is, let's say, in the negative direction and the F2, the other force is in the positive direction. So this parallel force are acting, and the movement due to these two forces is actually a couple. So it could be like this, or sorry, or it could be like this. So it always contain a two force, or at least a two force of different sign, like this. It could be like F1 and F2. But the movement is a very basic or general quantity. The movement is just the action of force which turns the object. So movement is, for example, this is bar which is fixed at some axis. So movement is just the application of the forces which actually rotate this bar. And it depends on the magnitude of force, direction of force, and of course the normal distance. Couple is actually a movement which is caused by the two opposite forces which are parallel to each other. Yes, movement is a vector quantity. So the movement can be given more formally. The movement expression can be written as r cross f. So this r is the radial distance or the radial displacement vector, and f is the force. So both of these are the vector quantity, and therefore the movement is also a vector quantity. So in three-dimensional system, the movement can be represented by, this is our ijk, so this is our rx, ry, rz, and fx, fy, and fz. So for a higher dimension, for all the cases, for the general case, the movement is mathematically actually defined by this. If you solve this matrix, if you simplify this matrix, then you will actually get the components of the movement, which is in terms of fr or sine cosine terms, sine or cosine term, depending on the component of the movement. So in the previous one here, we just took this components directly because it is easy to visualize. It's a two-dimensional system, and you can easily verify which is the normal distance. So for example, this is your bar and there is a force here F, and you have to find the moment about point O. So you can easily visualize if my force is acting in the vertical direction, the normal distance is the horizontal direction. But in a complicated problems like 3D or higher dimensional problem, it may be pretty much difficult. So in that case, it's better to always go through this general expression where you define the displacement vector and the force vector, and you take the cross product of it to define the movement. So for example, let me explain with some very simple or basic stuff about the direction of the movement once again. So we will be solving more question related to it, so it will get clear.
Okay,
let
let
me
me
define
define
a
a
bar
bar
here.
here.
So
So
you
you
have
have
a some
some
bar
bar
which is fixed at this point O. And let's say there are multiple forces which are acting. Let's say this is your F1, this is your F2, and this is your F3. Now, when you, and let's say this is a, again, this is the another force F4. Now, in order to find the moment at point O, we need to find the moment here at a point O. So, what we have discussed in the earlier question, that first figure out what are the component of force. So here we don't need to find the component of any force because all the forces are either in horizontal or in vertical component. Either it is in x direction or y direction. So first figure out the forces. So you have four forces. Okay. So the first force is we have a normal direction with O, which is given by x, or let's say d1. D1, this is your normal direction of force F1 to O. Similarly, this for the force F2, the normal direction is from O is D2. So your F1 and F2 will create a movement. And you can say the same thing for force F3 as well. Because you have both F and the normal direction which are non-zero quantity. And this is actually a magnitude of a movement. And here force and the normal distance both are non-zero quantity, which means this also F3 also will create a movement. Now F4 gives a no normal direction. It is actually acting at the point O. So this F4 will not create a movement. So you identify only F1, F3 and F2 is creating movement, not F4. Now you need to check the direction. So earlier we put counterclockwise as a positive direction. Let's say now we are putting counterclockwise as the negative direction, and clockwise is my positive direction. So you can choose anything. You can choose counterclockwise either positive or negative. Same with the clockwise direction. So now what happens? You need to find the movement at about point O. So just visualize, just imagine when there is a movement, the force F1 is rotating towards O. This force F1 is rotating towards O, and you see this is the counterclockwise direction. So what happens when you write the moment summation of movement? You will have a minus sign because you decided that my counterclockwise should be in the minus way. So you have a minus F1 D1. The same you can do with F3. So if you want to visualize the movement of F3 about O, so it will be doing this movement about O and come back to here. So again, this is counterclockwise. So you will write minus F3 D3. But with F2 now, what is happening? The F2 about O will go like this. It is going like this and come back. So the F2 is actually going clockwise direction. So the movement due to F2 is positive. Positive F2 D2. So this will be your movement equation. So you have to, in order to decide the signs, just visualize about a specific point O and how the forces, the movement due to forces is actually going. If you, let's say you need to find the movement at some point here, which is located here, A. There is a bar ahead, and you now same you have a same forces, same system. Just you need to calculate the movement around A. You do the same similar exercise. Like for F3, about point A, it is going in the clockwise direction. Similarly for F1, about point A going in the clockwise direction. Whereas F2 here, about point A going in the counterclockwise direction. So about point A, what happens? We will have positive F1, positive movement due to F3, and the negative movement due to F2. So this is your movement along point A. So this is how you actually visualize in order to decide the sign.
And
And
this is
this is
what we
what
have
we have
done
done
here.
here.
We
We
have done
have
the
done the
similar
similar
exercise
exercise
here
here
with the
with the
component of
component
the
of the
forces,
forces,
because
because
forces
forces
is
is
exerting
exerting
in an
in an
inclined
inclined
manner.
manner.
So
So
we
we
first
first
determine the
determine the
component of
component
the
of the
forces
forces
in the
in the
vertical
vertical
and in
and
the
in the
horizontal
horizontal
direction,
direction.
and we
And we
have
have
done
done
the
the
same
same
exercise
exercise
like
like
this
this
in
in
order to
order to create
define
define
the
the
signs.
signs.
Is it
Is it
clear?
clear?
So
So
let's
let's
move to
move
the
to the
next
next
question.
question.
So here
So
we
here
have a
we have a
five
five
forces
forces
act on a
act on a
link
link
in a
in
gear
a gear
shifting
shifting
mechanism of
mechanism
a
of a
lawn mower.
lawnmower.
The
The
vector
vector
sum
sum
of the
of the
five
five
forces on the
forces on the
bar
bar
is
is
0.
0.
The sum
The
of
sum
their
of their
movement
movement
about
about
point
point
where the
where the
forces
forces
AX
AX
and
and
AY
AY
act is
act is
0.
0.
Determine the
Determine the
forces
forces
AX,
AX,
AY
AY,
and B.
and B.
Determine the
Determine the
sum of
sum of
movement of the
movement of the
forces
forces
about the
about the
point
point
where
where
the
the
force
force
acts
acts
BX.
BX.
So this
So this
question
question
again
again
will
will
further
further
clear the
clear the
concept. So
concept. So
basically it's
basically,
the
it's the
same thing.
same thing.
First,
First,
we need
we
to
need
figure
to
out
figure out
the
the
unknown
unknown
forces, which
forces, which
is
is
AX,
AX,
AY,
AY,
and B.
and B.
And then we
And then
need
we
to
need
find
to
the
find the
movement
movement
along
along
the
the
point B.
point B.
So
So
as
as
discussed in
discussed
the
in the
earlier
earlier
question,
question,
we have
we
a
have a
three
three
unknown
unknown
here,
here,
and
and
now
now
we
we
need a
need a
three
three
equations.
equations.
So as
So as
somebody
somebody
asked
asks
earlier
earlier
that
that
why we
why
are
we are
not
not
using the
using the
moment
moment
equation,
equation, why
we
we
are
are
only
only
using the
using the
force
force
balance
balance
summation of
summation of
force
force
equation
equation
to
to
in our
in our
calculation.
calculation.
But
But
here,
here,
since we
since we
have
have
three
three
unknown,
unknown,
we
we
need to
need to
use the
use the
three
three
equation.
equation.
The
The
two
two
equation will
equation will
come
come
from
from
the
the
summation of
summation of
force in
force
the
in the
x and
x
y
and y
component,
component,
and the
and the
one
one
equation will
equation will
come
come
when
when
we
we
do the
do the
movement
movement
summation of
summation
the
of the
movement.
movement.
And the
And the
overall
overall
summation of
summation of
forces and
forces and
movement
movement
is
is
given
given
0
zero
because it
because it
shows here
shows here
the
the
vector sum
vector
of the
sum of the
forces, which
forces,
means
which
the
means the
vector
vector
forces is
forces is
0,
zero,
which
which
means
means
the
the
x
x
component of
component of
this
this
resultant
resultant
force
force
and the
and the
y
y
component
component
of
of
this
this
resultant
resultant
force
force
will
will
also
also
be
be
0.
zero.
And
And
also the
also the
sum of
sum
their
of their
movement
movement
about the
about the
point
point
A
A
is
is
0.
zero.
So
So
here
here
the
the
summation
summation
of
of
movement is
movement is
also
also
0.
zero.
So
So
if we
if we
take
take
the
the
movement
movement
about
about
this
this
point
point
A,
A,
let's say
let's say
this is
this
my
is my
point
point
A,
A,
so the
so the
overall
overall
summation of
summation of
movement
movement
is
is
will be
will be
0.
zero.
So
So
this is
this is
what we
what we
have
have
given.
given.
So
So
this is
this
the
is the
two
two
condition we
condition we
have
have
given,
given,
and
and
these are
these
the
are the
three
three
unknowns.
unknowns.
So
So
let's
let's
define the
define the
three
three
equation
equation
first
first
because
because
there are
there are
three
three
unknowns.
unknowns.
So
So
first,
first,
let's
let's
define
define
the
the
let's
let's
do the
do the
summation of
summation of
forces in
forces
the
in the
x
x
direction.
direction.
So the
So the
summation of
summation of
force in the
force in
x
the x
direction is
direction is
0
zero
because
because
here the
here the
resultant
resultant
force is
force is
0.
zero.
So in
So
the
in the
x
x
direction we
direction we
will
will
have
have
ax.
ax.
So
So
we will
we
have
will have
this
this
ax.
ax.
We will
We will
have
have
the
the
component
component
of
of
this
this
25
25
kilonewton.
kilonewton.
So we
So we
have
have
25,
25,
and this
and
is
this is
my
my
25cos
25
20,
cos 20,
which is
which
in
is
the
in the
x
x
direction.
direction.
So
So
it
it
will
will
be
be
25
25
cos
cos
20
20
plus
plus
b,
b,
and
and
then
then
there is
there is
a
a
component of
component of
this
this
force,
force,
which
which
is
is
30
30
cos
cos
45,
45,
and it
and it
is
is
exerting in
exerting
the
in the
negative
negative
direction.
direction.
So it will
So
be
it will be
minus
minus
30
30
cos
cos
45.
45.
equal to
equal to
0.
0.
So
So
this is
this is
my
my
equation
equation
1.
1.
Then
Then
the
the
summation
summation
of
of
force
force
in the
in the
y
y
direction,
direction,
which
which
will
will
give
give
me
me
Ay,
Ay,
and
and
this
this
component of
component of
force,
force,
this
this
one,
one,
or
or I
this
this
one,
one,
which
which
is
is
25
25
sine
sine
20.
20.
This
This
component of
component of
force,
force,
which
which
is
is
30
30
sine
sine
45.
45,
30
30
sine
sine
45
45
plus
plus
25
25
sine
sine
20.
20.
So
So
this is
this
my
is my
equation
equation
2.
2.
And
And
then
then
we are
we are
doing the
doing the
movement
movement
balance
balance
about
about
point
point
A,
A,
because
because
it's
it's
written
written
that
that
at
at
point A
point
the
A the
overall
overall
moment is
moment is
0.
0.
So
So
now the
now the
contribution will
contribution
be
will be
coming
coming
from
from
the
the
third,
third,
sorry,
sorry,
30
30
sine
sine
45
45
here,
here,
and
and
this is
this is
my
my
perpendicular
perpendicular
distance
distance,
and
and
due
due
to
to
25
25
sine
sine
20,
20,
and this
and
will
this
be
will be
my
my
perpendicular
perpendicular
distance
distance
or the
or the
normal
normal
distance
distance
from
from
point
point
A.
A.
And
And
also
also
from
from
B,
B,
because
because
we
we
have,
have,
so
so
by
by
using
using
the
the
line
line
of
of
action
action
here,
here,
so I
so I
can
can
draw
draw
B
B
here,
here.
because as I
Because as I
said,
said,
you can
you can
actually
actually
slide
slide
the
the
force
force
along the
along the
line of
line of
action.
action.
So
So
this is
this
my
is my
perpendicular
perpendicular
distance
distance
for
for
B.
B.
So
So
now
now
let me
let me
decide
decide
the
the
counterclockwise
counterclockwise
as the
as the
positive
positive
and the
and the
clockwise
clockwise
as the
as the
negative
negative
direction.
direction.
So
So
this
this
force
force
create a
create a
movement in
movement in
the
the
counterclockwise
counterclockwise
direction,
direction,
which
which
is
is
positive,
positive,
and
and
this
this
force is
force is
also
also
creating
creating
the
the
positive
positive
movement,
movement,
and
and
B is
B is
also
also
creating a
creating a
positive
positive
movement
movement
because it
because
will
it
go
will go
like
like
this.
this.
So all
So
the
all the
movements
movements
are
are
positive,
positive,
so
so
it will
it
be
will be
25
25
sine
sine
20
20
multiply
multiply
650
650
plus
plus
350
350
10 to
10
the
to the
power
power
3
3
meter.
meter.
I'm
I'm
writing in
writing
the
in the
meter
meter
here,
here,
plus
plus
30
30
sine
sine
45
45
multiply with
multiply with
650 plus B multiplied by 650 by 1000 equals to 0. So this will be my equation 3. So now you can actually calculate it. So first let's consider the equation number 2, which is AY plus 30 sine 45 plus 25 sine 20. So your AY will be minus 30 sine 45 plus 25 sine 20. So it will give me 21.213 plus 8.55, and my AY will be minus 29.75 kilonewton. So now I can equate, or we can solve equation 3 alone to get the unknown B. So from equation 3 we will get 8.55 multiplied by 0.65 plus 0.35 plus 30. So this will be 21.213 multiplied by 0.65 equals minus 0.65. So it will be 8.55 plus 13.7885 divided by 0.65, and this whole quantity is minus. So it will give me minus 34.353 kilonewton. So this is my B, which suggests that it is actually acting in the opposite direction. Now we have left with AX only, and we can use equation 1 to calculate it. So it will be AX plus 23.492, and this is minus 34.353 minus 21.213 equal to 0. So my AX is minus 10.86 minus 21.213. So AX will be 32.073 kilonewton. So we found AX, we found B, which is this, and AY. So here we got the three unknowns, and by three equation, two from force and one from moment balance, we found three unknown quantity. Now the second part is determine the sum of the moment of the forces about a point where the force B acts. So now we need to find the moment along this point now. This this is equation 3. Well, I guess I think I have yeah, this was my equation number 3 here. Yes, so it is 13.7. This come from the second point. Okay. So this is your B, this is your AY. I forgot AX. So did you remember the AX I found? I think it was around 31 kilonewton. I don't exactly remember. So have you note down the magnitude of AX we found? So anyway, let's solve the second part of the question. So in the second part, we need to calculate the moment about this point. So the component will be this 25 kilonewton cos 20, and then there will be AY, which is creating the movement, and there is 30 sine 45, which is actually creating the movement here. So the movement alone B will be given as. So I'm still sticking to counterclockwise, which is positive, and clockwise as negative. So it will be 30 sine 45 multiplied by 0.35, and then not the AY, the AX will create the movement. No, sorry, I think it's both. So minus AY 1, and then there is a 25 cos 20, which is creating a clockwise again. So it is 25 cos 20.45, and then there will be AX. At distance 0.65. So my moment balance will be minus 21.213 minus plus 29.75, which was my AY, and this will be minus sorry, here it's multiplied by 0.35. This is 10.571 minus, if AX is 31, then it's 31 multiplied by 0.65, which will give me 20.15. And this quantity is minus 21.21 multiplied by 0.35, which is 7.4235. Then I will get Here I will get 22.33 minus 20.15 equals 2.18 kilonewton meter. So this will be my movement along B direction. So any question? Or let's solve one more question about the movement. Then we can actually discuss about movement if you have a question. So here we have a space. Here we have a space shuttles, attitude, thrusters exert two forces of magnitude, which is 7.7 kilonewtons. What moment do the thrusters exert above the center of mass G? So let's make a free body diagram. So we have a two thrusters here, which is actually exerting a forces, which is 7.7 kilonewton. And let's say this is my center of gravity. And the force are acting here. F, which is at 5 degree. And here 5 degree. And this distance is 2.2 meter. And this is 18 meter. And this is 12 meter. So here we need to calculate the moment around point G. So first consider this front part. So let's say this is my front and this is my rear. So in the front part, my force will be, moment due to force will be and my clockwise direction is negative and counterclockwise direction is positive. And this is my vertical component of F and this is my horizontal component of F. So from the horizontal component in the front, or let's define the overall movement here, or let's write for the front only, in this part only. So it will be Fx cos 5 multiplied by 2.2, and it is acting along the clockwise, so it will be minus. And from the Fy, it is also acting along the clockwise. So the force, direction of force is here. So it is acting along the counterclockwise direction, not the clockwise. So it's a positive, so it will be Fy sine 5 and the distance will be 18. And from the rear, this is our Fy and this is our Fx. So in the rear also, you will have Fy, which is negative because it is going in the clockwise, which is negative. So it is minus Fy multiply by sine 5 multiply by 12 plus, so this is Fx, which is going in the clockwise direction. So this is the direction. So it is plus Fx cos 5 multiplied by 2.2. So this is my front and rear movement equation about G. So this is about G here. Now we can sum both this movement. So it will be Fx cos 5 multiplied by 2.2 plus Fy sine 5 multiplied by 18 minus Fy sine 5 multiplied by 12 plus Fx cos 5 multiplied by 2.2. So this and this is cancelled, and this is the movement around G. So on calculating this quantity, we will get mg equals, so my force is 7.7. So this is just the component of the forces, which is 7.7 sine 5 multiplied by 18 minus 7.7 sine 5 multiplied by 12. So it will be 7.7 sine 5, and taking common with 18 minus 12. So it will be 7.7 sine 5 multiplied by 6. So this will give you the moment, which is 4 kilonewton meter. So now any question about the movements? Or in the previous one? So let's see one more question about the same. So here we have the bracket, which is subjected to three forces and a couple. If you represent the system by a force F, what is F and where does its line of action intersect the x-axis? So first we need to find the force F, and that can be easily found by using the summation rule. And then we have to find the line of action where this force F is located along the x-axis. So here we have an x-axis. So this line of action is actually along this x-axis. So the force might be here, or might be here, or might be here, or might be here, or so on. And in order to find the line of action, what we will do, we will use the moment summation of movement. So it will give me this component r by d, which is equal to the summation of movement. because RYD, because this is my RY forces, and the RX forces, which is the another horizontal component of force F, it is actually uh, on the line of action here. So the contribution due to RX will be zero, and only non-zero contribution is coming from the RYD, which is the non-zero contribution to the movement, and we will be already finding RY and RX from the summation of forces. Once we get RY and RX, then we will use the movement balance to calculate D, which is the line of, which is the location where the force F is acting. So first do the force balance here, which is Fx. So the total horizontal forces are this 400 Newton and 200 Newton. So it will give you directly 200 Newton. Well, it can act couple. So if you want to find the movement, let's say around this point, then it will act a couple. So you have to solve this. You have to take the moment of this two equation and then calculate the overall movement here. So it can act because these are in the opposite direction and these are parallel. But the magnitude is different here. The magnitude is actually different. So no, so what happens in the couple? You have three conditions. So first is there will be at least two forces and it should be of opposite nature. It can be parallel. And there is a finite movement. Which is acting due to a couple. So here in the system, there is a finite movement. They have opposite nature and they are parallel to each other. But in the couple, what happens? The net resultant force is zero. And here the net resultant force is not zero. It is actually 200. So this system cannot be a couple. Because in the couple what happens, we have opposite forces and that should be equal also. Yeah, so here the net resultant force in the x direction is 200 Newton and similarly in the y direction it is 180 Newton. So this is my horizontal component of force and this is my vertical component of force. Now we need to find the reaction. So let's find the reaction from at point O, because when we will be finding the direct distance, normal distance D, we can able to get it from point of this from the same point O. So the moment at O will be, so let's say here my again clockwise is negative, counterclockwise is positive. So for 400, this is my negative direction. So it's minus 400 multiplied by 0.6. So for 200, this is my counterclockwise direction. So it will be plus 200 multiplied by 0.2. Plus there is a movement which is acting. So we will be just adding this. So plus, and this movement is along the counterclockwise direction, which is positive. Then there will be a movement due to 180, force 180. And it's again counterclockwise, which means it's positive. Which is equal to RYD plus Rx some normal distance. Now Rx is at the line of action here. This is your actually Rx, and you have to find where is your Ry. So Rx is at the line of action, so it will not create any movement. Only Ryd is. So yes, so it will be acting everywhere. So here you will get 400 multiplied by 0.6, which is 240 plus 40 plus 140 plus 117 equals 180 D. So your D will be 537 divided by 180, which is 2.98. Really? It's coming. Oh, sorry. This is minus, right? Okay.
Sir, why only Fy is considered? Ry is considered and not Frx in the moment equation?
Because Rx will not creating any movement because it's is along the x-axis, which is actually the line of action, and there will be a no movement along the line of action. So for example, if let's say this is your force F, and you need to create a movement around this point. So its line of action is this. So this force will not create any movement along this point because this point is located at the line of action. So there will be no normal distances. So there will be a no movement. Because in the question it is written that we need to find the distance D from the is along the x-axis, and there is a Rx component which is acting along the x-axis, and therefore it will not create any movement along point O. If there is a force F here or here, then it can create the movement along this point. But if the force which is located at this line where there is a point, then there will be no movement.
Yeah, but how it is ascertained over here that it is acting at point O?
Because this is the x component of the force. It should be acting along the x component. So there will be some component of force F here, and then there will be some component of force which is Ry. So we took its component Rx and Ry. The Rx will always be in the x-axis, and Ry is always along the y-axis or the parallel to it. Now we need to find the distance of this component of this force, which is actually D from the origin O. So we are actually solving the moment balance equation to calculate this distance. And it is given in the question because it's a line of action intersect with the x-axis. So it is given that this Rx actually along the x-axis. It is not like here or here. It is actually lies along the line of intersection of the x-axis. So therefore this force will not contribute to any movement.
Okay.
Yeah. So this is not 537, yeah. This is 57 and it will give you 0.316. So your distance is 0.316, which means that the RY is somewhere located here. This is where your RY located. And this is the vector of overall force, and this is your Rx, which is, as per given in the question, is at the line of intersection of x-axis. And you can define the angle as theta by using tan theta equals Ry by Rx, which is basically 9 by 10. Theta is approximately tan inverse 0.9, and theta will be approximately here in degrees will be around 40 to somewhere around 40 and 45. So any further question?
So can I have this all problems written somewhere so we can try it later?
Yeah, sure. So I will upload this PDF in the Google Drive, as well as there are some problems left as well, which is based on the same principle. So you can try solving this problem.
That's better you upload this problem, unsolved problem also we can try.
Yeah. So I will upload this. So try the remaining problems from this PDF, and we can discuss them in the next class.
Yeah. So Google Drive link will be shared by sir on the mail.
Yeah, sure. I have to create the Google Drive. Then I will, I guess NPTEL people will share the Drive link.
Okay. But one more thing, sir, the problems which are common in assignment and the problems which are discussed over here, I'm finding that there's a lot of difficulty level in the assignment problem.
In the assignment problem.
Yeah.
I think the assignment problem are pretty much fine, because here first my objective was to start with a very simple problem and then go to a little tougher one. So you can see there are multiple equations you are solving here. The system is little complicated. In the assignment problem is actually based on your basics. Like if you have a basics clear, then it will be solved very easily. Otherwise, you may find it difficult. But try to, if you try to solve all this question, and then I hope you can be able to solve those questions as well, because those question also, the methodology is same. Even in those questions you have to do the moment and force balance only. But
Okay. Okay, we'll try on the assignment also. If there is any difficulty, I will get it in the next week discussion.
Yeah, so for the assignment is actually a different tasks. Then this tutorial video. So until you have a deadline of an assignment, I cannot discuss the assignment questions.
Yeah, we can discuss it after this deadline is over.
Sure. Okay, then that's it for today's class. And
Thank you very much.
yeah, thank you.
I have a doubt.
Yeah, sure.
Will you please go to that 7th problem?
Yeah.
Here this 140 Newton meter is acting, right? But my doubt is, for this 140 Newton meter, the center point is not O, right?
Yeah. So this movement will be acting, the same movement will be acting along the at O also. Because for example, let's say you have a cantilever bar. Or imagine this is your pen. Okay, you are actually holding a pen like this. So this is your pen. You are actually holding, and you are actually applying some movement here. So whatever the moment you are applying here, let's say you are applying moment n here, there will be a opposite moment which is applying at this end. Okay, because of this fixed joint, there will be a same moment which will be here, which is actually restricting this pen to turn. So if my pen is not turning and if I am applying the movement, the same movement will be here also, and the same movement will across in this direction. There will be a same movement across all the horizontal direction. So you have to consider the same movement here, which is applying to the all horizontal direction, because it's same here, here, and here also. Because you don't need to multiply any distance or anything here because it's already in the Newton meter. And this whole movement is actually will be applying at this point O also, because this point is actually trying to avoiding the rotation of the body, which means the same movement is applying here, whatever you are producing here.
Okay, so okay.
Okay then. See you in the next class. The same time, like Sunday 3 to 5. No. So this is a weekly tutorial class, so it will always happen at the same time on a weekly basis. Okay then.